Learn Concrete Estimating. Lesson 2. Calculating Weight of Rebar. Part 2. Lap Splice Tables. In this lesson, you will be learning how to figure lap splice value from lap splice tables in an alternative simple method. As per ACI, American Concrete Institute, this is the tension lap splice table for 3,000, 4,000, and 5,000 psi concrete elements. Tension tables have higher values than compression tables. If you are estimating rebar for concrete elements under compression, such as concrete columns, you can use compression tables. For the estimating purpose, we will be using tension splice tables since they have higher values. Unit for values in these tables are inches. It may look complicated, but no worries. We will cross out some rows and columns that we don't need. For example, for the lap class section, we will cross out all Class A values, and for the Case 1 and 2 selection, we will cross out all Case 2 values. So basically, we just need to know PSI of the concrete and location of the rebar for top bar selection. Now let's go back and explain how we made our selections for lap class A or B, top or other bar, and Case 1 or 2. You can find concrete PSI and class of concrete information in the General Structural Notes page of structural drawings. Usually, it is the first page of the structural set and commonly called as S01 or F01. When you find General Structural Notes page, look for Concrete Notes. In Concrete Notes, we just need to find and highlight PSI value of the concrete. In this case, Note 2 calling for 4,000 PSI concrete, but these notes are not giving us information about class of concrete. Class A concrete is usually used on government projects such as roadways, pavements, and bridges, and Class B is generally used on residential and commercial buildings. If concrete class is not specified, we will make our class selection as Class B. For now, we will be estimating for buildings, so our class selection is Class B. Now we have 4,000 psi concrete, so let's cross out other concrete PSI values. And we know our class selection is B, so we can cross out all Class A values. Then, we just need to select top bars or other bars. Location of the rebar will determine top bar or other bar selection in the table. Basically, if rebar is located above minimum 12 inches concrete, that will be considered as top rebar. So wall horizontal rebars are considered as top bars. All vertical bars or dowels are considered as other bars. Bottom continuous bars are considered as other bars as well, because they are not above minimum 12 inches of concrete. In mat slab, rebar at the top layer is top rebar, because it has 3 feet of concrete below. So when we are calculating the weight of top rebar, we will use top bar lap splice value. When we calculate bottom rebar, we will use other bar lap splice value. So we need both top bar or other bar lap splice values depending on bar location. And one last thing we need to know is case value, Case 1 or Case 2. First, we need to learn about concrete cover. Concrete cover is the distance from face of concrete to face of rebar, not from the center of rebar to face of concrete. It is face of concrete to face of rebar. This value is given by ACI, or it may be specified in project documents. Usually 3 inches for footings, 2 inches for grade beams, 1.5 inches for walls and columns. And we already know rebar diameters are 3/8 of an inch to 11/8 inch, and spacing of rebar can be anywhere from 3 inches to 5 feet. First condition of Case 2 is if concrete cover is less than bar diameter. Let's change rebar diameter values to decimals. 3 divided by 8 equals 0.375, and 11 divided by 8 equals 1.375. As you can see, minimum concrete cover value for common structures is 1.5 inches, and it is bigger than all rebar diameters, so first condition of Case 2 does not apply. Second condition of Case 2 is if spacing is less than 2 times the bar diameter. When you multiply largest bar diameter by 2, 1.375 inches times 2 equals 2.75 inches, and minimum rebar spacing is 3 inches, and it is bigger than 2 times of any rebar diameter. So we can say Case 2 doesn't apply for common residential and commercial buildings. Now we can cross out Case 2 values. And finally, this is our lap splice table for this lesson. Top bar values are bigger values. If we compare number 10 size rebar's top and other bar values, 102 inches top bar and 79-inch bottom bar. Difference is 23 inches in between. It is very important to use top bar lap splice value for rebar located above 12 inches of concrete. 23 inches difference may cost the contractor thousands of dollars. Remember, for any horizontal rebar above 12 inches or more concrete, use top bar lap splice. Alternative method is bar diameter method. I don't recommend using this method, but sometimes it is handy if you need to do some quick calculations. We already know how to figure bar diameter from Lesson 2. Basically, dividing the size of the rebar by 8 will give us bar diameter. For example, for number 5 size rebar, divide 5 by 8 equals 0.625 inches. For top bars, use 60 dB, and for other bars, use 48 dB. dB stands for diameter of bar. For number 5 size rebar, top bars 60 times 0.625 equals 37.5 inches and rounds up to 38 inches. And the same way for bottom bars, 48 times 0.625 equals 30 inches. If we compare 4,000 psi values from lap splice table against bar diameter method, number 3 to number 6, this method gives slightly close numbers. But number 7 to number 11 difference increase as rebar size increase. I don't recommend using this method for rebar estimation. Just use this method to get an idea for a quick calculation. Don't use it for rebar estimation. In the next lesson, we will cover standard hooks and we will start doing some examples.